In this example, the question says, verify that. If y equals to 1/16 x to the 4th is a solution to the differential equation y prime equals to x times square root of y. Well, as you can see, you have an explicit function. You have left-hand side and right-hand side. So let us write down the left-hand side of the equation, which is the first derivative, and the right-hand side is x times square root of y. I'm going to check to see if these two are equal to each other for this explicit function. So y is equal to 1/16 x to the 4th. Of course, we can take the derivative. It is 4 divided by 16 x to the 3rd, or the first derivative of the function is 1/4 x to the 3rd. Let us substitute that for the left-hand side. Well, 1/4 x cubed is on the left. What is on the right? X times square root of y. What is y? Y is 1/16 x to the 4th. So you get x times square root of 1/16 x to the 4th. So let us go back to algebra. Simplify this. We get x 1/4 x squared, which is 1/4 x cubed. Are they equal to each other? Of course, they are equal to each other. And it means that we just showed that this explicit function is a solution for differential equation. So our conclusion is y equals to 1/16 x to the 4th is a solution for the ordinary differential equation. You can write down the equation here, y prime equals to x times square root of y. Let us make it more interesting. Let's check another explicit function and verify that if that function is a solution of our differential equation or not. So verify that y equals to x times e to the x is a solution of differential equation is given to us as the second derivative of y minus 2y prime plus y equal to 0. Okay. As usual, left-hand side, right-hand side. Left-hand side of the equation is the second derivative minus 2, the first derivative plus y, and on the right-hand side, we have 0. We want to check to see if left-hand side and right-hand side are equal to each other for this specific function. So this is my function. Y equals to x e to the x. Well, what do I need? By looking at the ordinary differential equation, you need the first derivative and also you need the second derivative. So we need to find the first derivative of this function. Here you have the multiplication between two functions. So we need to apply the product rule. So for product rule, y prime is equal to the derivative of x e to the x plus x times the derivative of e to the x product rule. So the first derivative of this function, the derivative of x is 1, e to the x plus x, the derivative of e to the x is e to the x. Very well. Now what? we have y prime. We also need the second derivative of the function. For the second derivative of the function, you're going to have the derivative of e to the x, which is e to the x, plus, now for x, e to the x, you have to apply the product rule again. We already know that the derivative of x, e to the x, is e to the x plus x, e to the x. So we're going to copy this guy down here. The first derivative and the second derivative. We need to substitute this into the left-hand side of the equation. Well, so let's see. The second derivative is 2 e to the x plus x e to the x minus, you have subtraction. Now 2 times the first derivative e to the x plus x e to the x plus y. What is y? Is x e to the x. I'm going to check to see if this guy, after simplification, is equal to 0 or not. So let me write this guy down here. Is it equal to 0 or not? So that's why we put the question mark on top of it. So we're going to distribute -2 into parentheses. We get 2 e to the x plus x e to the x minus 2 e to the x minus 2x e to the x plus x e to the x. Okay. You can cancel out the opposite terms. X e to the x to the x, 2x e to the x. So we can cancel out the whole thing. On the left-hand side, you have 0. On the right-hand side, you also have 0. It means that the equation satisfies this differential equation. So the conclusion is y equals to x e to the x is a solution to the ODE, which is the second derivative of y minus 2, first derivative of y plus y equal to 0.